Hi, in this video, we'll be solving a dependent system of equations in three unknowns. Okay, first of all, we need to try to get one of the variables to cancel out. So we'll be taking row 1 plus row 2 to get the x values to cancel out. And this is our first step. It's always a good idea to keep track of what you're doing and just make yourself notes so that if you have to go back and find a mistake, you can remind yourself what you did. So if we add row 1 plus row 2, that will give us the x's cancel to 0. So we'll have y minus 4z equals negative 3. Okay, next I would like to combine row 1 plus row 3, again to get the x's to cancel out. You need to get the same variable to cancel out with a different pair of equations. But in order to do this, in order to get that 5x in row 3 to cancel out, we need to take row 1 times negative 5. So doing that, and I'll just make myself a note here that we're taking row 1 times negative 5. So taking negative 5 times row 1 gives us negative 5x plus 5y plus 5z equals negative 10. And copying row 3, we have 5x minus 4y minus 9z equals 7. And now we can add together these two equations. The 5x and the negative 5x cancel to 0. 5y minus 4y is y. Then we have minus 4z equals negative 3. Okay, now our next step is to take these two equations in two unknowns, and we'll set up this new system of y minus 4z equals negative 3, and the other equation is also y minus 4z equals negative 3. So basically what we have here is two equations that are on top of each other. They're lines that are right on top of each other. And so adding these two equations together, we get 0 equals 0, which is always true. And so we have an infinite number of solutions. So instead of giving numerical answers, we're going to give this dependent set of equations as our answer. So we're going to let z represent any real number. And then we'll take our y minus 4z equals negative 3. And we're going to solve that for y in terms of z. So in other words, we'll just add 4z to both sides of this equation, leaving us with y is equal to 4z minus 3. And now to get x, we just need to plug that y value in for y in one of the original equations. So let's just plug it back into our row 1. And if we do that substitution, we'll have x minus the y of 4z minus 3 minus z is equal to 2. And solving that, we get x equals 5z minus 1.